Okay, I'm going over the how to write up the lab for this. Uh, there will be there's a quiz as well, and the quiz and the write up will be related to each other. What I would plan to do if I were you is to make sure you watch all the videos um, of this lab. Uh, you probably want to maybe watch all of them once, but then take the quiz. Um, and you can take you can watch the videos and take the quiz at the same time. Then you can do the lab. You can do it however you want. Just let you know you have the option. You can use the videos to do both the write up and the quiz. Okay, so let's go over it because it's fairly complicated because there's like three or four or five steps here that you need to do, and so you need to make sure you're staying on track. So the first thing that I did in the lab was I came up with a standard curve, and what I did is I had some specific concentrations of the iron thiocyanate, and I put them in the spectrophotometer and I measured the absorbance at 535, and then I wrote down the values here. Okay, and if you notice, is the concentrations here go 4, 8, 12, 16. Is that from basically from this value on, okay, they doubled. So let's say that's not, but you'll have to watch the video to actually get the real number. But let's say this is 3, okay, then this one will be about 6, 9, and 12, okay? So you'll see a linear relationship between that, okay? And then you have you have your concentration of your iron thiocyanate, and then you have your absorbance, and you'll get a curve. It's a straight line. It's going to vary a little bit from a straight line, but what you want to do is find the best fit for that straight line. And there's different available programs to do out there. And you can use the calculator. You can look up best fit, and it's easy enough. So when you do that, you put in X, you put this column, and in the Y, you put up this column, and then you'll end up getting a equation that says Y equals M, and they'll give you a value for M, and then B, and they'll give you a value for B, and hopefully you guys know what those mean. M is slope, B is the y-intercept. Okay, so what I really would like to do, you have this equation, and write it down. Okay, make sure you write that down in the report. Write down these values and write down the equation that you get here, but rewrite the equation in this form here. Okay, so where you substitute y with A because absorbance is the y-axis, and x is substituted with the FESCN. And so you have A equals M, the slope, and iron thiocyanate. By the way, this equation A equals some constant times the concentration. Okay, and this is M, and usually we don't worry about B because we assume that goes down to 0. So this is standard equation for Beer's law. It says the concentration is related to the absorbance with this as the constant. Now this is called epsilon, and it's also known as the extinction coefficient. So this M here can be actually replaced by E, little e, and that's how we would do it in the if you really wanted to write this in like a scientific paper, you write it E and then a concentration of FECN and so forth. Okay, but you don't have to do that. I'm just giving you an idea how this is really written up. Okay, so you have this equation, and now what we're going to do is go to the next step. Okay, so in the next step, I did an experiment where I actually ran the experiment, and what I did is what we're going to do is we measure the absorbance again of the FeSN. Now remember that this is your product, so you have Fe 3 plus. We can leave that off, plus the SCN yields Fe SCN. Okay. All right. So this is your product, and this is equilibrium. Okay. So so what you're measuring is the amount of FeSCN at equilibrium. Okay. All right. And so what we do is so trial B, and all these are just trials of the same experiment, basically. So you have an absorbance here, absorbance here, absorbance here, absorbance here, absorbance here. So how do you figure out this value with your given absorbance? Well, from your previous equation, you got A equals M times concentration of FeCN plus B. Okay, and so you have absorbance. Okay, you have M, you have B, and you want to solve for this right here. So what you do is you just simply rearrange this equation for solving for this right here. Okay, and after you do that, you take the value that I got here, put it in that, so rearrange it so the equation is equal to, I'm not going to do it for you because that's part of your, okay, so this equals something, okay, that you derive over here. Then what you do is you plug in your absorbance. So our absorbance over here, you plug in your M, you plug in your B, and you'll come up with concentration of FeSCN. Okay, and you do that for all 5. So write those down. And just show me one calculation how you did that. So this equation here, so rearrange the equation, and then use that equation. So plug in the appropriate M, B, and A to show how you got 2B, all right? Okay, next thing we want to do is we want to find out what were our initial concentrations of the iron and thiocyanate. So, because this is we want to know the initial, so you can figure out how much you have at equilibrium. So this is fairly simple how to do. You take for 1B, I took 50 mils. Okay, 50 mils of 0.002 molar iron nitrate, and really just concentrate on Fe. And then we put it in a 100 ml solution. Okay, so so you added 50 mils of the nitric acid. Okay, so what is the molarity of the iron in this 100 mils? Okay, the way to do that is first of all figure out how many moles of iron there are in the 50 mils. So 50 mils is 0.05. So to figure out moles, you do molarity times liters. You can see that the liters cancel out. And then when you do that, you end up getting, then you got how many moles, okay, of Fe. And then to figure out the molarity, you divide it by 0.1 liters, which is 100 mils. And that'll give you the molarity of your iron. Okay, now for the SCN, you do the same thing, same kind of thing. You take 0.02 molarity, okay, times 10 mils, 0.01, and that'll give you how many moles of the SCN. Okay, and then what you do is you divide it by 0.1, and that'll give you the molarity of your SCN. If you notice, the iron is the same for all of them, while the concentration of the SCN is going to be different for each of the Bs. So, okay. Next step. Okay, so now you're going to take those calculations that you just we did in the last one. So let me go back and look at number 1B. So number 1B, it took 0.02 moles per liter times 50 mils, and then divided by 0.1 liters, 100 mils, and you get 0.001, and you put it here. And then the SCN, you did 0.002 times 10 mils, or 0.01 divided by 0.1, and you put that one here. Then go ahead and fill and do this for each one of the other 9 or 8. Okay. All right. Okay. Now we're going to get something out of this. So hopefully remember this is the ice tables that we went over in equilibrium, and let's go back and let me talk a bit. So let's set it up. So this is our equation. Fe plus thiocyanate gives me iron thiocyanate. Okay, and it's at equilibrium, goes back and forth. So, and what we're to look at 1B, okay? So 1B says the concentration is 0.001. This concentration is 0.0002. And at the beginning, we have no product, all right? So once the reaction takes place and it's come to equilibrium, some of the iron is turned into product and some of the SN's product, and then you have this. Well, we know this value here. Okay, you just go back to slide 3, okay, or part B's calculations where you found the concentration of FeSCN, okay, and that number will go right here. This is for 1B. And then what you do is, since that's how much is gained, since you start, this becomes a plus x. Now, since the relation's 1 to 1 to 1, okay, for every one of these form, you lose one of these and one of these, okay? So take minus x off of each one of these. And so you end up having whatever value you get here, you subtract from the 0.0002 and the 0.001, and show the calculations for each of the all 5, 1 through B. And so you should have you'll have you'll have the equilibrium concentration of iron, the SCN, and your product. Okay. So let's put it together. All right. So next thing you do is you come up with the Kc of each of these solutions, okay? And so what you do is you take the value, so if you just look at 1B, and that's from our previous one, 1B, you take this concentration, you take this concentration, this is the equilibrium concentration, this is not, so this is the 0.001 minus x, and this is the 0.0002 minus x, right? And then you simply do the math here, and then you put your value here. And then you do the same thing for 2B, 3B, 4B, and 5B. Okay, and show your calculations. Okay. And then, all right, after you get done with that, you'll have the 5. And then you should take an average of all the 5 to come up with your average Kc. for this equation, what you're going to notice is that these numbers should be pretty close around 1500, I think. So somewhere between 1000 and 1500. The first one's going to be much higher, maybe 10 times higher. Anytime you get a value that's 10 times different than other values, you can kind of throw that out. So that to figure out the average, it's just it's the magnet. It's too much to too large or too small. That'll affect the rest of the data. Uh, so so anytime, so I believe this number is around 15,000, but I could be wrong. I can't remember. But you can leave this one out if it's between five 10 times greater than the rest of them. And then, but make sure you show that you did that and explain why you did that. All right, so there you go. That's how you do this lab, and hopefully, uh, that'll help figure out how to do it.